Hey all, it's Altbeer here, and I just wanted to get this latest Badge Diaries uploaded, but then I realized the live stream had no audio. So I'm going to be doing a quick voiceover at 2x speed to just give you an overview of where we're at and what we did in the stream. So here what I'm doing is plugging in the prototype dev board and the breadboard, and showing how I got all four NeoPixels to work using the 3.3 volt rail off of the ESP32. Originally, we were planning on doing power direct from the battery because we thought the power draw was going to be pretty high for these. But these little guys that we got are not drawing very much power at all. And so, with the capacitors in line with the LEDs, we got these NeoPixels all powered on using the 3 volt rail, and it's pulling a very low current. So even with them all at fully white bright, so this was a good thing, and that's how we're going to start doing the design. So we agreed to start working on the schematic at this point to build that out so that we can start doing the PCB work. We only have one of the regular LEDs hooked up, but all of those are pretty simple. So the test here was with the NeoPixels specifically. Okay, so now we're opening up the EDA KiCad, and we're opening up the schematic editor and showing off the new schematic I made for the ESP32 dev board, which by request of the badge team, I made it line up with the physical layout of the board. That way it's easy to look at on this diagram and match it up to the physical settings, and it has all of the pin information on there, so that it's easy to tell what's what by looking at the schematic, and you can line it up with the physical board for when you're doing prototyping and whatnot. And so yeah, I decided to start building out the schematic for the NeoPixels in the using the same pins and in the same design that I have on the breadboard. This way, some of the other members of the badge team can build this out themselves on their own breadboards until we get a prototype board going. And I'm just explaining how I'm using the different symbols here for the power, as well as the labels for the other things. That way you don't have a million lines crossing each other. And then my OCD kicks in, and I'm like, oh no, if I try to do ground and power and where they're at, it's not going to work. Oh, here we're talking about the capacitors and how I put them in line between the ground and the 3 volt rail. But I'm going to document that on the schematic next to each NeoPixel, and not next to the actual ESP. So yeah, there was some concern that we might have to use bigger capacitors, but it turns out that the 100 NF, which is like the recommended for that NeoPixel, they seem to work fine with it being on the 3 volt rail. I thought we might need some bigger capacitors if it was going to draw a little too much, but yeah, it's not working. And yeah, still need to figure out how to best do that to get the power looking better on that side. The beauty of these labels in the KiCad schematic editor is it makes for a nice clean design, because I could just use that same label elsewhere and I don't have to draw a line all the way across the page. And so we'll see as we build out this schematic how we do that. Now, a question was raised about if I had the pins correct on my schematic, and so I think here's where we're going to dive into looking at how I came up with this schematic and how I determined which pin was where. And yeah, I believe we're talking about the where the voltage in is on this board, because we're not doing voltage going directly to the NeoPixels. All right, and so now we're doing more talk about the ESP layout, and here you can see me pulling up that schematic, and then these were the capacitors that we're going to put in line for the each of the NeoPixels is going to get its capacitor. So we're just kind of dumping those on the screen right now to start building that out. And more discussion about what pins we're going to use for the other things, like where the touch is going to go and where the other LEDs are going to pin out to. Since the two pins for the NeoPixel strips that we're going to use are GPIO 18 and 19, and we decided on two strips of NeoPixels, even though there's only 2 pixels per strip, because the first one is going to be for the flames on the tires, and the second one's going to be for the lightning. Oh, and here's where the question came up of, are you sure you got that pin out right? And so yeah, we started looking at the actual layout of the pins and making sure that was correct. And now we're going to open up the footprint editor just to check out what the footprint is that's associated with this schematic. And I believe because I cleared the cache out, this took a very long time to open because I have a lot of footprints and it has to rebuild the cache file. So we were just chatting away while we were waiting for this thing to open. So you can see why I 2x the speed on this. There was lots of chatting and waiting. And here we are opening up the footprint that I put together that has some of the references of where the antenna is and where the USB is, and it matches up to the schematic pins. And then I think I looked at the original one that I downloaded off the site, and it matches up identically. It's just that one has drill holes that we didn't need. But you can see they have the antenna and the USB in the same spots. So yeah, this was just double confirmation that the schematic was actually accurate. And now we're going to start building out the rest of the schematic for the NeoPixel designs. We'll just kind of try to make this all line up as pretty as possible without crossing any lines. Yeah, and I kept selecting lines when I wanted to delete them. More examples of me learning how to use this new version of KiCad, because things in KiCad 5 were a little different as far as how things operated. I love 6, but there's a learning curve there if you're used to 5. Just simple things like if you single click or double click things, it works a little differently. And you can see we have that one built out. And now we're going to cut and paste the data in label and then create a new label for data out. And I believe because the data out label name is a little large, we're going to have to move some stuff around to accommodate it. And at 2x speed, this actually looks like I know what I'm doing, where I was struggling to work with this on the live stream. And then we had some discussion about how we're going to label the different components I think we decided on 11 and 12 for the neopixels on strip 1, and then 21 and 22 for the neopixels on strip 2. And then we'll make the capacitor names match so that you know which capacitor is associated with which component. And here I'm duplicating the second one in strip 1. So this is the 12, D12. And now we got to flip because the data out becomes the data in. And that's done. All right, and then I just put a little no connect on the second data out since we're not connecting anything to that. And next we're going to do the strip 2 for those second neopixels, and basically I'll just duplicate these and rename things. And we'll just rename the labels. And the beautiful thing about the labels is when you convert this schematic to the PCB editor, it keeps track of those labels and will connect all the lines together correctly for you. So that way it tells you where you need traces. All right, and so to match this up with the breadboard, we're just keeping a single one of these two LED, the dual LEDs, two color LED. That's the term I'm looking for. So we'll just wire up a single one the way I had it on the breadboard. We could add the rest later, but for now, just making it match the breadboard so that the rest of the badge team could build out this breadboard using this schematic. And this was us figuring out what to number these, since we used the 11 series and the 10 series and the 20 series for the neopixels. We decided to use 30 for this, and so I think we said 31 and 32 because this is a dual color LED, so it actually has two anodes. So 31 will be the first anode, 32 will be the second anode. And then we'll just put those in onto the GPIOs that I have them in the breadboard. And then it looks like I covered up the ground piece there, but we hooked up ground, and now we're going to hook up the two labels to the anodes. And the schematic is about done for now, so we'll just double check. And I think, what was I labeling here? Oh yeah, I had some trouble finding the net list. Oh, this is the touch pin, sorry. Yeah, we had to add the touch pin in where that's going, although we didn't put in any other components for touch at this point, even though I have them wired into the breadboard. But then I was going to dump a net list file from this schematic to then import from the PCB, and maybe there's an easy way to do this in KiCad 6 that I wasn't aware of. In 5, there was a button that was just net list, and I had trouble finding it here, so I had to actually go to the drop-down menus to find export, and then I used export net list to create that file. And I think this is me trying to struggle to find where the hell the button is that's no longer there. And we found the export, and now we're going to try to export the net list, but apparently you have to hit the annotate button, and I didn't realize that, so I thought I exported it and I didn't. And so we'll go over to the PCB editor and try to find the netlist file, which doesn't exist. And once again, there was no import netlist button here, where I was used to that in 5, so I did the import from the menu, and oops, there's no netlist here. Let's go back here and try to generate it again. Annotate. Yes, now it saved the file. And so now when we do import, we import the netlist, found the file, and what I was showing here was how it puts like all the components down that it has footprints for, and it will draw the little lines connecting the components. These are not traces, this is just showing you like reference lines, like this is connected to this, that way you don't put a trace down in the wrong thing. So it's very helpful. And so now I'm talking about the new footprints that I made for these. It loaded the old footprints, and so I'm going to show how to change the footprint for something. And so I'm just showing where I made a new footprint and how you would select that. And then you would say okay, but I think I canceled out of here, and so we'll go back in, do it again, and I remember what I was doing. I was trying to change the source instead of the destination, because you have two lines. One is source footprint and one is destination footprint. So this is, you're going to change everything with the source to that destination. And so once I changed it to the destination, you can see it changed all 4 of those NeoPixels to my new footprint that has the cool little LED leg length graphic on it. So you can tell which pin is the long pin, which pin is the short pin, and where they go in which hole. And then I did a similar thing for the 2-color LED. I had a new footprint for that one that also has the little graphic showing where the long pin and short pin go. So it has that on the side. This way there's no confusion if somebody's looking at the LED and trying to figure out how it goes into the through holes. They can have that handy reference. And I was talking about how I need to do a new capacitor footprint as well that has the silk on the front, but I decided to save that for now. And then we just started discussing more about how we have to add the rest of the LEDs to this before we can build out the rest of the schematic and start building out the PCB. So at this point, we are going to be ready probably to send a prototype, to get a prototype PCB to manufacturing soon, hopefully by next week. So yeah, that's what we're discussing here, is what else is going to need to go on here to make that happen. Now we're doing a quick code review of the code that I wrote to make this work with all 4 NeoPixels doing their color wheel, and the 2-color LED going back and forth between the two. And so yeah, there's just a review of the code, and I'm not gonna try to walk through it in a voiceover, but yeah, the basics are we're setting up all of the pins initially. For the PWN, we have to set the frequency and some other items, and then for the NeoPixels, you have to choose like the RGB versus GRB as far as the order of the colors, as well as the frequency for that as well. And so all of that gets done in definitions, where we're defining the pins for the different things. Um, and I'm just explaining all that here. And then we have some counters that we use, um, that the uh, counters are used for the threshold of the touch pin. And now I'm talking about the setup. And so the setup is like a run once code, where we have to initialize everything. So that's where we're setting up like the channels for the PWM, as well as initializing the NeoPixels, and setting our serial interface. And then when we get into the loop, I have a delay, which is going to show that that's the stop time where it displays the color. So that's adjustable. And then I have a single for loop for everything, where I'm just running 0 to 255 for everything. And then I'm using a position counter, which I'm going to modify, that's based on the iteration counter. And based on that, I'm going to iterate what red, green, and blue is on the NeoPixels, and the on and off of the two colors on the two color LED. And I have this broken up into an if statement, where if it's less than 85, if it's less than 170, etc., because that is 1/3 of 255. So this allows me to do 3 different groupings within the 0 to 255 range, and use the position counter by just resetting what position is equal to have it start at 0 again. And that's why I'm multiplying it by 3 or by 6 in this case, because for the 2 position LEDs, I actually wanted 4 transitions, right? So you have on, off, instead of 3 transitions, which would be on, on again. It would look weird. So that this way it has 2 on, off slow and on, off quick for each of the 2 positions. And then I talk about the touch pin and how it's going to print to the screen, and that's basically it for the code review. And since we made a bunch of changes during this session, I'm just going ahead and closing everything out so that I can push this up to the GitHub. Right now, the GitHub repo for this is private for the badge team members only, but hopefully in the next 2 to 3 weeks, we'll go ahead and make that public, and then everyone can see the code and the EDA and everything else. But yeah, all I'm really doing here is in my feature branch, I'm doing a pull, and then an add, and then a commit, and then we'll do a push. Yeah, so there's my commit, and we'll do a git push, and this pushes up the code to my feature branch. And then because of some recent mistakes I made using GitHub, for many of my repos, I've turned on protection for the main branch. So what that does, it's a very simple protection. Everyone can still approve their own pull requests, but it requires a pull request in the main. So to get this into the mainline code, I had to do the push into my feature branch and then do a pull request into main. It's just a little safety feature to make sure you're actually looking at it and did I really mean to put that in the main? And so yeah, little safety valve. So no additional approvals needed, but yeah, it's something that's helpful if you're working with GitHub to make sure you don't damage your main branch. And then we're wrapping up here, just talking about future plans for how we're going to move forward with a Kickstarter, which we would like to get the Kickstarter launched hopefully in the next week or so. That way people can see what we have, but that's why we're pushing to get a prototype out to manufacturing by next week. Once we get that done, we should be able to have enough artifacts to put together for a Kickstarter campaign. So if you're following along here, be looking forward to that, and hopefully we will have this next session with some audio, so you won't have to listen to a dry voiceover. But thank you for attending, and as always, we appreciate everyone who is into Badge Life and wants to watch these Badge Life diaries as we build our DEF CON 31 future badge. Thanks all for attending.